Hi everyone. So in this video we are now talking about capillary and the surface tension. This is the under the subject of fluid mechanics. Okay. So let us first define the surface tension of a fluid. So surface tension of a fluid from inside the liquid to the surface to form a new unit area of that surface. So the pressure inside the droplet of a liquid formed by the surface tension. So surface tension is the property of the surface of a liquid that allows it to resist an external force due to cohesive nature of its molecules. Okay. So to fully understand for this definition, we have this example. So by observing this illustration, so have you ever wondered that why does the insect can walk on water? So for explanation for that matter, so we have assume that this illustration is water molecules. Okay, so we know that all molecules are attracted to each other. So the forces between molecules in a liquid are stand with all neighboring molecules, and that's what we call cohesive force. So the cohesive forces between liquid molecules are responsible for the phenomenon known as the surface tension. And the cohesive force between molecules in a liquid are with all neighboring molecules. Those on the surface have no neighboring molecules above, and those exhibit stronger attractive forces upon their nearest neighbor on and below the surfaces. So, for fully explanation for that, we know nga in this area, this surface of these molecules have wala na neighboring no. Wa na siya laing or water molecules with nga maka attract sa usag-usa, which means na para ma-balance ang usa ka forces nila between this, so dapat ang kaning forces diri in this area is greater than forces nga na diri nga area sa molecules. Okay, so mo na maka-tends to contract to each other to minimize the area between this all of these molecules in and which allow to resist the expansion or the stretching between this atomic band nga mo-occur og forces kana siya or weight sa usa ka object. So such as a small insect such as the water strider can walk on water because their weight is not enough to penetrate the surface. Okay? So kung ma-overcome niya ang force nga naa diri nga area ha, this kani kung ma-overcome niya ang forces due to sa iyang weight itself, so ang iyang body is masubmerged into water. So that's why nga ang all ubang insect nga gamay rag height nga na gamay rag height, so dili siya di na makapenetrate o masubmerge ang iyahang body sa water. Okay. So surface tension in droplets. Surface tension is responsible for the shape of liquid droplets. Okay. Although easily deformed, droplets of water tend to be pulled into a spherical shape by the cohesive force of the surface layer. So, nakabantay mo sa inyong faucet nga maka-form siya og droplets. That is due to the surface tension. Okay? So for the illustration for this droplets, liquid droplets, okay, we have this diagram. Okay, so sa kani nga diagram, we have spherical or soap bubble or droplets. Okay, if we cut this and turns out into this free body diagram, na we know that na mo occur into forces this dere around this circle of this kanang hemispherical, and nasay mo occur nga pressure inside this spherical, and the projected area nga iyang ma-occur, this distributed forces is mo na ang area sa circle. We have projected area is equals to pi r squared. So in terms of equilibrium condition, we can manipulate by doing this equation. Summation of forces x or horizontal is equals to 0. And your saan siya? Right direction is equals to left direction nga forces. So mag-focus ata sa right forces. Right direction nga forces. So sa right direction nga forces, we have the pressure air inside this hemispherical. So pressure inside is equals to pi r squared. So the projected area for the pressure inside is the area of the circle, is equivalent to the surface tension around this circumference of the circle. We have surface tension na tagsa-tagsa ka surface tension, but in terms of total of kuan man kani circumference, mao na nga times na to 2 pi r. So surface tension times 2 pi r. Okay, so let us continue. So we know that we can cancel out the pi in the r, this equation. So the equation becomes like this: pressure inside times r is equals to surface tension times 2. And we can say that your r is diameter over 2, right? So pressure inside times the diameter over 2 is equals to surface tension times 2. Or your equation becomes like this. So pressure inside is equals to 4 times surface tension over the diameter. So where P is equals to pressure inside, and your surface tension, and the D is the diameter of droplets. So let us proceed to capillarity. So capillarity is the rise and fall of a fluid in a capillary tube, which is caused by the surface tension. And then the capillary action or capillarity is described the ability of a liquid to flow against gravity in a narrow space such as a tin. Okay, and then unsay nakakos ana nga deformation sa kana nga liquid, and that is causing by or the outcome of the two opposing forces. So unsa to mga opposing forces nato? The cohesion and the adhesion. So sa cohesion ato itong na-discuss earlier, but what about the adhesion? So adhesion is the attractive forces between dissimilar molecules or atoms. In our case, the contact area between the particles of the liquid and the particles forming the tube. Okay, so depends on the relative magnitude of the cohesion of a liquid and adhesion of the liquid to the walls of the containing vessel. So they said that if your adhesion is greater than cohesion, makaingon ta nga, makakonclude ta that your uh, that your deformation or the capillarity it will rise. But vice versa, or contrast for that, that your cohesion is, and they say that your cohesion is greater than adhesion. So your condition of the deformation, the liquid becomes, it will fall, or kaingon ta nga mo nagiingon nga capillarity depression. Ah, so for the wetting fluid, for the for describing for this rise and fall, so we have this illustration. Okay, so for the rise we have this. So ang iyang contact angle, so the strength of the capillarity effect is quantified by the contact, or wetting angle theta is defined as the angle that the tangent of the liquid surface makes with the solid surface at the point of contact. So kung ingani ni-rise ang iyang deformation so sa liquid, so imong theta becomes like this, nga nira ka angle nga ma-make niya. But in angle depression, so ingani pod yung ma-make nga theta. So in comparison between the capillary rise and capillary depression, we have this illustration. So this is the typical illustration for the capillary rise and the typical illustration for the capillary depression. Okay. So to equate or to formulate the equation of the capillarity, formula of capillarity, we have to consider this free body diagram that I presented here. So let F is equals to force due to surface tension. So we know that F is in terms of upward direction. So if we sum up all of this surface tension around this circle, siya. So we know that this direction of surface tension is along with the tangent of this curve kani. So mo na maka-create og angle niya between the vertical direction. Maka-create og angle. So we can say that maka-form sa tag triangle dire, di ba? So by forming the triangle dire, creating a triangle, you can say that your forces vertical or surface tension vertical is equivalent to surface tension times cosine theta. This is a adjacent part of the triangle. Kani. So surface tension vertical is equivalent to surface tension cosine theta. And if the total surface tension around this circle is equivalent to our forces nga atong gi-present dire. And for the weight of the capillary volume, we have this weight. So force due to surface tension, we have this equation as I explained earlier. Weight is equals to, we know that weight is equals to gamma volume. So our volume is equivalent to pi over 4 d squared times height, di ba? In terms of cylinder nga volume. So by equilibrium condition, we have summation forces vertical is equals to 0. So for the upward direction, we have force. In the downward direction, we have weight. So forces, by equating or substituting this equation, we have this nga ni atong form sa ato ang equation. So pi d times surface tension cosine theta is equals to pi over 4 gamma times d squared times height. Okay. So we can cancel out the diameter in the pi, So wala na cancel dire. So our equation becomes like this. Surface tension cosine theta is equals to 1/4 times gamma times diameter times height. Or pwede ma-form na to ang equation into ngani. H is equals to 4 times surface tension cosine theta over gamma d, where H is equals to capillary rise or depression in terms of the unit of mm or inches, and the surface tension is Newton per meter or lb per feet. In the diameter, d is equals to diameter of the tube or inches. So the unit weight of a fluid, either Newton per meter cube yung unit or pounds per feet cube yung unit. So we have the standard for angle of the water, no, which is theta is equals to 0 degrees if the condition is complete wetting. So for mercury, we have theta is equals to 140 degrees. So this is based on the experimentation of kaning angle. So let us have an example. So example number 1. So determine the surface tension in water having a pressure of 10 Pascal if the diameter of a tube is 1.5 centimeter. Okay. So for the solution for this problem, we have the given data that given for the problem. P is equals to 10 Pascal or 10 Newton per meter squared, or equivalent to 10 times 10 to the power of negative 6 Newton per millimeter squared. And D is equals to 1.5 centimeter is equals to 1.5 or equivalent to 15 millimeter. Okay. We know that the formula of the surface tension in terms of liquid droplet, we have P is equals to 4 times surface tension over D, or the diameter. Or the surface tension is equals to PD over 4. By substituting this data from this formula, we have this. So for computing, 10 times 10 to the power of negative 6 times 15 over 4. Okay. So we have this answer. We have our value nga itong na came up. Or 3.57. So murag na sayop sa answer, no? So nga na, basta nga na pag compute niya sa kaninga problem. So example number 2. We have this problem. Compute the capillary depression for mercury in a capillary tube 3 mm in diameter if surface tension is equals to 0.514 Newton per meter. So for the solution for that, we have this given problem. Surface tension is equals to 0.514 Newton per meter, and D equals to 3 millimeter or 0.003 meter. So for the capillary depression for mercury, we have this formula. H is equals to 4 times surface tension cosine theta over gamma d. So for the standard angle of mercury, we have theta is equals to 140 degrees. H is equals to 4 times surface tension, we have 0.514 and cosine 140 over the specific weight or specific weight of the mercury, we have 9810. So we can say that your specific gravity, or we can uh, equate the specific gravity in terms of specific weight, or the specific weight of the substance over the specific weight of the water. So mao na ang siya. So we know that the specific gravity of the mercury is equivalent to 13.6. So 9810 times 13.6 times the diameter of the capillary tube 0.003 meter. So by computing for this, so 4 times 0.514 times the cosine 140 all over 9810 times 13.6 times 0.003. So we have this value, negative 3.935 times 10 to the power of negative 3, or negative 0.0394 millimeter, or equivalent to negative point 3 negative 3.94 millimeter. So which means nag-negative man siya, ang ato ang condition sa usa ka capillarity, nagkuan siya capillary depression, ang iyang deformation sa usa ka liquid. So for the example number 3, determine the capillary rise of a certain fluid in a capillarity tube having a diameter of 2.5 mm if its weight angle and the surface tension are 90 degrees. So nanay condition nga angle which is 90 degrees and 0.0756 Newton per meter respectively. So for the solution, we have this given problem. Surface tension, we have 0.0756 Newton per meter. In diameter, we have 2.5 millimeter, or equivalent to 0.0025 meter. And the theta, we have 90 degrees. We know that the formula of capillary rise of the fluid have this equation. H is equals to 4 times surface tension cosine theta over gamma d. So by substituting this data, we have 4 times 0.0756 times cosine 90 ni siya nga angle. Cosine 90 degrees over the gamma times 0.0025. So wa man siya nagisgot og unsa siya nga fluid, ingon naman siya nga certain fluid. So ato lang yani ang iyang gamma. But we know that our cosine 90 is equivalent to 0, no? So here, diri nga value is equivalent to 0. So 0 over the kani nga equivalent kani nga value, so h will become 0 gihapon. So which means 0 man ang ato ang capillary rise. So which means why nahitabo nga deformation sa usa ka liquid. Okay? So that's all for now, and thank you for listening and have a good day.